everybody. Today we're going to be covering section 9.7, which is on ocean acidification. The learning objective for today is that you can explain the causes and effects of ocean acidification. Some of the essential knowledge that you're going to gain is what ocean acidification is, what causes it, some of the impacts that can be happening, all that stuff. So we're going to start by talking about what ocean acidification is and what causes it. Now, one of the things that's really important to remember is that what's happening in the atmosphere also happens in the ocean. So as we get increased carbon dioxide levels in the atmosphere, this causes increased ocean carbon dioxide because of direct exchange, which means that the atmosphere and the ocean are directly exchanging this carbon dioxide. Now, what happens is we're going to have a little bit of chemistry with this one. Carbon dioxide combines with ocean water, H2O, to form carbonic acid, which we can see in this diagram here. As we get carbon dioxide dissolving in with water, this creates carbonic acid. And if you look at following the atoms with this equation, we've got a carbon atom, we have two oxygen atoms here, and a third oxygen, which leads to these atoms here in this part of the equation. We had two hydrogen from the water, which gives us two hydrogen in the carbonic acid. And so these two together form carbonic acid. Now we have a second step in this process. Carbonic acid dissociates into bicarbonate ions, which is HCO3 little negative. What that means is that they gave up a hydrogen ion. So if we look here, you are going to have this hydrogen ion pop off on its own, which is going to leave this bicarbonate ion. Now, one of the things to remember is that when we look at pH just means your concentration of hydrogen. So to be more acidic, that means you have more hydrogen ions occurring. So as we are getting this carbon dioxide and this carbonate acid, which then pops off the hydrogen ion, this means that we're having more and more hydrogen ions in the water, which means the water is becoming more and more acidic. So I gave you right here, this is important for you to know this step-by-step equation here, how we go from carbon dioxide and water, which forms that carbonic acid, which then forms the hydrogen ion and the bicarbonate ion right there. You could sort of skip this middle step, and if you were to just draw the equation, just do carbon dioxide plus water creates hydrogen ion plus HCO3, the bicarbonate ion. But kind of knowing the step-by-step of how this occurs, you need to know that. You at least need to know the start and the finish, but it's helpful for knowing the step-by-step of how this happens. But again, this is what causes the ocean acidification. So now, how does this relate to marine organisms? Marine organisms that make shells use calcium ions, which exist in the water, and carbonate ions. Again, these both just exist in our saltwater oceans. And they use these to build their calcium carbonate shells. That's why they're called calcium carbonate. Calcium plus carbonate equals calcium carbonate shells. This calcification where they make it. Now, the problem is, as carbon dioxide increases and the ocean acidifies more, this is going to make the carbonate ions less available. So let's look right here. Now, if we are going to have normal situations where we don't have tons of carbon dioxide occurring, we are going to have these carbonate ions just floating around in the water here. And it is going to make it so that you can have coral and mollusks, which are organisms with shells, able to just make their shells normally. However, when we end up having our pH going down, it's getting more acidic, we're having more carbon dioxide, as we just talked about in the last slide, this is going to be forming that carbonic acid. And then you are going to be having these little carbonate ions meeting up with these free hydrogen ions, which is going to be creating more bicarbonate. And which means we have a bunch of bicarbonate, but we don't have these just like normal carbonate ions by themselves, which means we no longer have this available for the marine organisms to make their shells. because these ions have bonded with the carbonate and formed that bicarbonate. So we no longer have the carbonic acid available, the carbonate ions available. Now, there's two things that happen with this. First of all, as our ocean gets more acidic, marine shells are just going to break down, and we are going to have less of this carbonate ion able to be soluble in the ocean water. But then we're also going to have fewer carbonate ions, which means less option or less of the building blocks of these shells, so that they are not able to form anymore, and you get weaker and weaker shells. So weaker shells in formation, and then also weaker shells from pH just dissolving them. So overall, you're going to have these organisms that rely on shells not being able to form their shells properly, and that's going to be a big problem for them. So if you look at this diagram right here, this shows a shell deterioration in pH of 7.8, which usually oceans are higher. Their oceans are usually a little bit more basic. So as we are looking at this, we put it in a more acidic solution. You can literally see these shells like dissolving over time in these more acidic conditions than what they're used to. So now let's look at climate change and ocean acidification. Hopefully, by this point in the year, you are aware of what things cause ocean acidification. But just a quick recap, we've got fossil fuel combustion, I restated that sentence wrong. Hopefully by this point in the year, you know what releases more carbon dioxide. There we go. So recap of that. Things like fossil fuel combustion release carbon dioxide. Deforestation releases the carbon dioxide that was in those trees. Coal and gas combustion is going to form our SOx and our NOx, which cause acid rain, which make more acid water. So all of this is going to be causing our ocean acidification. Now, carbon dioxide increase is directly correlated with ocean acidification, as I just talked about, because the hydrogen ions are released. So we get an inverse relationship between carbon dioxide and ocean pH. So as carbon dioxide increases, pH decreases, and decreasing pH means it's more acidic. So if we look at this diagram right here, this shows us that exact correlation from 1985 to 2005. As carbon dioxide increased, ocean acidity decreased. They have an inverse relationship. Now, ocean pH has decreased from 8.2 to 8.1 in the past 150 years and could decrease to 7.8 by 2100. And remember, the picture that I just showed you of that dissolving shell, that was 7.8. So although it doesn't sound like very much, one of the things that you need to remember is that pH is a logarithmic scale, which means that a decrease from 8.2 to 8.1 is actually a 30% decrease. So these small changes actually are very drastic, and it can lead to catastrophic implications for the organisms that are living in these oceans, especially those that have a very, very small range of tolerance. Okay, so this will be your practice FRQ for 9.7. I want you to identify a human activity that leads to the ocean acidification, and then explain how ocean acidification can threaten marine organisms. That is your practice FRQ for 9.7. Those are your notes on 9.7 about ocean acidification.